Everybody just do that. Okay, Stephen, over to you. Thank you.
Okay, so my presentation will be a bit more technical. I apologize in advance for that. But this follows on very nicely from Tira's presentation, because it talks about how to kind of, at a technical level, how to actually achieve at least our kind of ongoing work in terms of how to achieve or to facilitate, in our case, interdisciplinary learning, but also kind of interdisciplinary modeling and kind of participatory modeling. So today I'm Stephen Knox. I am a software engineer at the University of Manchester in the UK. I've been working on this project for almost 10 years now, and it's an ongoing thing. It's a very, very difficult problem, as we all know. And today I'm going to be talking about facilitating interdisciplinary learning about interdependent resource systems using online integrated models. It's a bit of a mouthful, but what we're kind of trying to solve at the Future Dams, in the Future Dams project, is this idea that if you want to create a holistic view of an entire system, not just the water system, but the thing as a whole, you need to take into consideration the water system, the energy system, the food system, and the environment at the very least. And there's lots of other things, but also not only do you need to kind of consider all of these things, you also need to consider the interdependencies between them. One example here is hydropower plants. So hydropower plants, they store water for irrigation, and anyone who knows anything about water is kind of very comfortable with that. But one thing that we're kind of less comfortable in the water sector is with how the energy produced from hydropower plants, how is that used? And from an energy point of view, it's very important to be able to understand how energy can be produced quickly based on from hydropower plants, because that's one of their big advantages. Hydropower plants, so thermal plants in an energy system use water for cooling, so then they have a demand from thermal plants, and they have this kind of feedback mechanism into the water system, and then obviously electricity can be produced or can be used to then produce potable water. So there's a very kind of clear interdependency between the energy system and the water system. But creating a holistic view of the system requires representing the individual system drivers. So what causes them, the systems to react? Then the processes, like what are the processes put in place in order to react to these system drivers, and then the interdependencies between them. The problem is when you're dealing with multiple sectors, and also when you're dealing with multiple countries, you're dealing with different levels of expertise, different levels of stakeholders. And very often these people have very little knowledge of the other sectors on which they are so interdependent. So the first question we're trying to answer in this project is, how can multiple users with different backgrounds and knowledge bases communicate effectively and work together? So if we break that down, we have multiple users, we have different backgrounds and knowledge bases. We want to try and make them communicate effectively, and we want to try and get them to work together. The second question is, how do we integrate domain-specific models into a single integrated system model? And what we mean by that is, we take, for example, a water model and an energy model, which might be developed completely independently by people speaking different languages, using different programming languages with different levels of expertise, at different granularities. One might be daily, one might be monthly. And how do we take those and combine them into a single model to create a better understanding of this system as a whole? So the answer to question one, as we propose, is to create a collaborative environment. It sounds reasonable enough. This allows users to collaborate. The most convenient way to do that, as we're all kind of sitting here watching web interfaces right now, is through a web interface. The ability to access and share data, and hopefully in a user-friendly environment. And this is aimed at modelers and stakeholders and decision makers. So it's not just aimed at modelers or not just aimed at decision makers, but it's aimed at the whole spectrum of users. And the answer to question 2, as we propose, is obviously to enable the integration of submodels. And that is to say, provide a framework in which submodels can be integrated. And we use, we've presented this several times at IMSS. It's a framework called PINSYM. It's a Python-based open source integration framework, where each submodel is described as being an engine, where each engine communicates with a central data store. And this requires some work to be done by each of the individual model developers to allow their model to be plugged in to the to PINSYM, but we've tried to make that as simple as possible. And that kind of piece of work typically involves just translating from one format of data to another format of data. So here's an example of a water energy system. On the blue lines here are the water system, and the red lines are the energy system. You can see that there are some points at which the hydropower at the top right hand corner there connects to a municipal supply with the water, but then it also supplies energy to the municipal supply, and as does the solar power. So what we would like to do within the Future Towns project is to run this entire system as one model, because this gives us a much better understanding of the dynamics of the system as a whole, rather than just the one water system or just the energy system. So what do we do? The way we do that is we break it up into 2 separate models. So you can see on the left, we've got the water model, on the right, we've got the energy model, and then we provide a framework, the PINSYM simulation at the top, where you can see that each of the dotted lines represents a communication that was in the previous image, a line that goes kind of directly from one node to another node. But instead of doing that, because that's not usually possible, we kind of abstract that. So then the water engine and the energy engine speak to the PINSYM simulation and communicate the information between the relevant nodes within each of the separate models. So what this has done is this has been used on for several of our projects now, and it basically allows us to create simulations of completely independent models, where each model is created and verified and run independently by their own experts. But then the experts work together on the PINSYM simulation, and that's the kind of focus that they have to help them communicate and help them work together. Now, in order to satisfy the second question, which is try to make it easy to use and try to make it kind of more palatable for those who don't like Python code, is the Hydra web interface. Now, it's a lot of words on this slide, so I'm not going to go through them too much, but this is a generalized web interface for network models. And it basically allows multiple people to log in and run models and kind of edit data and various things like that. If you can kind of imagine, it's like Google Docs, except for models. And the way this works is that you have multiple users logging in. We have this web interface section here in the middle that handles all of this traffic. And the kind of crucial thing here at the bottom is of the central section is the MATLAB model, Python model, et cetera, et cetera. So the idea here is that you can load up a model regardless of whether it's written in Python or MATLAB or, you know, Excel, and it will work with this interface, so long as there's a kind of a process put in place to allow that to work. And when you press the run button in the interface, that job goes into a queue and then it's eventually run. In our case, there's 2 separate processes. One is the water app. So the process for the water app is you press run in the interface. The app then says, okay, you've run network 123, go and get me that data. That produces an input file for your modeling system. The model then runs, and then once the model run has been completed, then it returns the data to the network. Exactly the same thing happens to the energy app, except in this case, it produces a different input file because the energy app and the water app are entirely separate things. And then integrating these two things together, we use PinSim. So you can see that in the central section here now we've got the water input file, energy input file, and finally a PinSim input file. We combine all those two things together into an integrated model and then save that data back to the network. So here's an example of the interface. You can see at the top left-hand corner, there's a green play button. That's exactly what I'm talking about. In the central section here, you can see a network. This is of Myanmar. This one is of the Tigris-Euphrates, Iraq, Iran, Syria system. This one is of a small system in the United Kingdom. And this one is kind of the one that we're talking about mainly today, which is the Volta River Basin in Ghana. So this is the water system of the in Ghana that we've been modeling through this system. This is the energy system. So you can see that they kind of look quite similar to each other, but also quite different in terms of the kind of coloring. So these two things are two different models loaded into the same system, being worked on by two different sets of people. And when you press the green button, it goes off and does some model runs in the background and on the cloud. And when you combine those two things together, the system allows you to combine those two networks into a single place. Now we have two sets of model developers who are able to go to a website, hydro.org.uk, log in and see both their network and the water network together on the same system.
3 minutes, Stephen.
Thank you. When they press the play button here, they'll have a couple of options. One is they'll be able to say, I want to run just the energy portion of this model, which will then go and run and will only update the relevant energy section of the model. Or you can choose to run the water section of the model. So that means that within what you're looking at here, you can run and verify both the water model and the energy model independently from the same screen. Or else you can choose to run the integrated model, which, like I said before, will download both the water model, the energy model, and a third kind of PinSim model, and run them all as one package, and then return results to this network. So I was going to show a demo, but I'm running out of time. So I'm going to leave it there. But what we're trying to do here is allow this ability for multiple modelers and engineers to log into a single system and run and access their own models within that system, all within kind of one package. What I didn't get to show, and I was going to do it in a demo, is the kind of stakeholder interaction type of aspect to this, where you can create lots of kind of dynamic graphs. You can share this network that you're looking at with whoever you want to. They'll get an email to say, Stephen has shared this network with you. You click on it and you'll see this network, and you can choose to see different types of metrics like we were talking about before, to say, the cost of this system is this, or the environmental impact of this piece of infrastructure is this. And there's kind of, not only is there a kind of a low level modeler kind of base to this, but there's also an aspect of being able to show this to decision makers and show the impacts of different decisions through this interface. And the whole thing kind of happens through this one web page.
Stephen, before you finish, Sue here,
Yeah.
hi. How long do you think that demo will take? We've got one question for you, but we do allow...
It can take anything from 1 minute to 3 hours. So let's go with the 1 minute version.
Let's go with the 1 minute. Yeah, I think
All right.
people would like to see it. Thanks.
Sure. Okay, so here is the system. This is a set of folders. You can think of them as folders. The one I'm going to go to is Model Suite that I've prepared for this. Inside of here, you can see that there's lots of different types of models. In the background of all of these different models, something different is happening. But the nice thing about the system is it allows you to just see the same, a very kind of similar kind of interface for everything. I'm clicking on the water, the Ghana water model. When I go in here, I can see the network itself. I can click on here on one of the nodes, and I can see some data. There's some flow data associated to this node, like so. So each of these values is editable. You can kind of navigate around this network and change values as you like. And then, like I was talking about before, you can click the run button, choose one of these. These are the different apps I was talking about. There's the energy or the, oh, there's my stopwatch. In this case, it's run PyWR, which is a Python-based water modeling system. And now you can see in just a second, we should see this blue box indicates that the model is running. So this is now deployed on the cloud somewhere on Amazon. It's now going to do some calculations and perform a simulation over this network. And while that's doing its thing, we can then see the.
I was going to say, Stephen, while it's doing its thing, you've got two questions. Maybe I'm sure you can multitask.
Sure,
first is, how did you decide on the level of detail in each of the model blocks? So it's a technical question, which is from Yuri. The second is from Alice, and who's the target users, decision makers? Do they all use the same interface, or do some people just receive the results? And you got 4 minutes. Go for it.
Okay, so the level of detail on this particular model is very much defined by the stakeholders, as in the people providing us with the data from Ghana. So they will have the details about the operating rules for the reservoirs and the flow data. And one of the issues that we've dealt with is that it's kind of I guess every modeler has dealt with the same kind of situation, is that it's kind of patchy. Some of the information is really excellent and some of it is less so. And then you have the energy sector, which again is quite the same thing. You have to go to the energy sector in Ghana and ask them for the data, and you're kind of bound by what they can provide. So I think for this one we have, let me see. Oh, that's the wrong network. I think it's weekly data. I can't remember, but it's not that fine-grained for this particular one. But then we have other models in this system which are daily data for 100 years. So it kind of depends on what you have available to you. But the system's able to kind of handle both kind of things. And what was the second question? Sorry,
Alice's question was, who's the targeted users? Does everybody use the same interface?
At the moment, it's modelers, because we're still at the stage of development where we need input from modelers in terms of just understanding how do you get two sets of modelers to connect to a system and work and help them work together, and what collaborative features do they need. But shameless plug, if you want to talk about more high-level users, like for example decision makers, on Thursday at 2:20, I'm doing a presentation on metrics. And metrics is a whole different kind of level to this, where you can share this network with users, with high-level users that aren't modelers, but you can turn off editability. So this is kind of like you can send people like a read-only version of this network and then you can send them metrics. And metrics is kind of high-level aggregations of some of the results. So that, if you're going to send this to a decision maker, they don't have to look at time series. They don't have to look at, unless they want to. They don't have to look at operating rules unless they want to. But that information is there for them should they want to see it. But the metrics provides a kind of a high-level aggregation for people who don't really understand the kind of details of the models. So it's, at the moment, we're developing it for and with modelers, but the idea is that within the kind of next 12 months, it'll be brought more and more into the decision-making process and kind of brought up the chain, so to speak.
Yeah.
So.
Well, thank you. Great answer. And could you just flick onto the metrics just quickly? So this will be part of your plug for Thursday. So people can,
Let me find an appropriate
quickly
model for you.
And at the same time, if our next speaker could be starting to get ready to think about how they might share their screen. Yep.
Oh, you put me on the spot now. I have to find the right one.
Sorry about that.
That's quite okay. Oh, I forgot to mention that there's also a workshop that will be a fully hands-on workshop with this. Oh, it's broken. I'd like to fix that. Oh no, sorry. There's this.
That's okay. You're out of time now,
I'd
Stephen.
have to add some metrics to this, so I'd have to add
Yeah,
some metrics. It's going
cool.
to take a while. So.
All right, but there's a workshop on what day?
On Thursday morning at 8 a.m. Central European time. That would be a fully hands-on tutorial on how to use this, and we'll be doing some analysis and stuff like that with this tool. So if you're interested, please join.
Fantastic. Thank you, Stephen. I'm the only person who can clap, but you know, yay. Thank you. People can always do a thumbs up.